Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asif Hilmi bin Rahman, ID student 2022 988157 from class CEEE 2233B. So today in this video I will present two tasks about multiple integration. Let's see the video. Alright, this is the graph or region for task 1 double integral by using mathematical application, which is GeoGebra. So here we have two range for x and range for y. Range for x is start from 4 minus y squared to 4, and range for y start from 0 to 2. After we combine the two range, we got the region, which is the black color or gray. So next we looks at the double integral, how to solve the double integral type 2 because of dx dy. Alright, this is the calculation for double integral for type 2 because of dx dy. First thing first, we need to integrate dx in terms of x, which is y exponential power of x. After we integrate x, we got y exponential power of 4 minus y exponential power of 4 divided by exponential y squared. Then we need to integrate in terms of y. Before that, we need to let u equal to y squared. After we let u equal to y squared, du over dy equal to 2y. Then we got dy equal to du over 2y. Then we substitute u into y squared. So we integrate the in terms of du, 1 minus 1 over eu du. We integrate du and we come out the coefficient, which is e exponential power of 4 over 2. We integrate the u, then we substitute again u equal to y squared. Then we substitute the number of range from 0 to 2. Then we got the answer 3 exponential power of 4 plus 1 over 2. So next we look to the reversing the order of integration, which is type 1 dy dx. So the answer must be same because of we change the type from type 2 into type 2 to type 1, which is dx dy to dy dx. Alright, this is the type 1, which is dy dx. First thing first, we need to draw the graph to see the region. And for type 1, we need to look from bottom to top, and then from left to the right. First thing first, we need to calculate the value of y, which is y squared equal to 4 minus x. So y equal to square root 4 minus x. So the range for y is from square root 4 minus x to 2, and range for x is 0 to 4. Then we integrate dy. We got the 1 over 2 integrate 0 to 4 to exponential power of x minus 4 minus x times with exponential power of x dx. Then we integrate dx, range from 0 to 4. After we integrate dx, we got the answer 3 exponential power of 4 plus 1 over 2. So the answer for type 1 dy dx is same with type 2 dx dy. Next, let's take a look for task 2, triple integral. Alright, this is task 2, which is triple integral. Here we have graph x, y, and z. So this graph was drawn by using mathematical application, which is GeoGebra, and this one is from x-axis. So we see that y and z is base, x is height, yz is base. So this is the shape of x equal to y squared, z equal to 0, and x plus z equal to 1. So this is the graph from x-axis, and yz is base. Next, let's take a look for y-axis from y-axis. This is y-axis, which is y equal to height, and x, z is base. This is the shape that show from y-axis, which is y equal to height. Next, this is the from z-axis, and xy is the base. Z equal to height, xy is base. So this is the shape of the graph, and we have the curve from negative 1 to 1, which is y x equal to y squared. Next, let's take a look the integral or calculation volume from x-axis, y-axis, and z-axis. Alright, this is for x-axis, which is x is consumed as height and yz is base. So first we need to find value of z and y. Z equal to 1 minus y squared, from y squared equal to 1 minus z, and y equal to square root 1 minus z. So when z equal to 0, z equal to 1 minus y squared, so y equal to plus minus 1. So that's why the value of y have 2, which is negative 1 and positive 1. So here is a triple integral. So we need to integrate dx first. Because of x, we assume as height, and dy dz is base. So after we integrate dx, dy, and dz, we got the answer is 8 over 15. So let's take a look from y-axis. Is that the answer is same or not after we change the height of graph from x to y and to z? Alright, this is for y-axis, which is y is height and x and z is base. First thing first, we need to draw the base, which is x and z, which is x plus z equal 1 and x equal to 1 minus z. And the second graph is x equal to y squared, and then we need to find the value of y, which is y square root x. Here we have two value, which is positive square root x and negative square root x, because of y squared. That is the special condition. So after that we need to integrate dy as a height and base dx dz. So range for dy is from negative square root x until to square root x. Range for dx is from 0 to 1 minus z, and dz is from 0 to 1. After we integrate dy, dx and dz, before that we need to substitute let u equal to 1 minus z. So du over dz equal to negative 1. Then we substitute into u with the range of dz. Then we got the answer 8 over 15. So the answer is same with x-axis. When x is height, yz is base, and from here y equal to height and x and z is base. So let's take a look for the last one, which is z is height and xy is base. Alright, this is for z-axis, which is z is height and the base is x and y. First thing first, we need to draw the graph for height and base. When x equal to 1, we substitute into x equal to y squared, and then we got the answer of y equal to two value, which is positive 1 and negative 1. So after that we need to integrate dz, dx, dy. Dz is height and dx, dy is base. So range for dz is from 0 to 1 minus x. Range for dx is from y squared and to y to 1, and range for dy is negative 1 to 1. So first we need to integrate dz first, and then dx, dy. So after we integrate all of three, dz, dx and dy, we got the same answer with x and y axis, which is 8 over 15. So here the conclusion is, when you change the height and base, the answer will same, but you need to be careful with the range of height, range of base, range of dz, range of dx, range of dy. Make sure the range is follow with dz, dx and dy. Follow the placement or follow the graph. Alright, that's all from me for multiple integration. See you again. Thank you.